every month or so, thereabouts. Oh, are we on?
I think you can hear
I hear
us.
a vague echo, so I think. Hands up in the back if you can hear me. Yep. Okay, we're on.
Okay, can someone in the back try to ask a question, and we'll tell you if we can hear you? No, I think that means you might need to come closer.
Or they're just very shy.
Oh, that's true. That's true.
Yeah.
We don't have enough microphones for everyone.
Yeah. So shyness is banned for the next 3 hours because this is, we hope, going to be a very interactive session. And really, that's up to you guys. Please stop us, ask us questions. Well, we'll explain the format in a second. Are we starting, by the way, officially? Looking at someone to give me a nod. Are we? No? I guess.
Are we starting the recording? Okay.
Yeah, okay.
We're good.
Good, right.
Right.
So we should do introductions first.
Okay, go ahead.
Okay. My name's Dick Wall. I am a software engineer for many years now. I've been working in Scala for about 4 or 5 of them, pretty much exclusively. I co-own a company called Escalate Software with Bill Venners, and we do Scala training and Scala consulting, and we're now Typesafe training partners.
Right.
And I don't want to curse it by saying anything more, but I think there's some stuff with consulting that we'll be doing soon with you guys as well.
The key is we're partners.
Yes.
Yeah.
I'm very good friends too.
Yeah.
Very good friends.
So I'm Josh Suereth. I'm the author of Scala In Depth, and I'm currently an engineer at Typesafe. I'm leading the tools team. We call ourselves Q because we need interesting names. So Q being the guy who does all the awesome stuff for James Bond, but doesn't have to actually get shot at by villains. Well, it's kind of a good gig.
He's also the omnipotent alien in
Star Trek,
as
which
well,
I do
right?
like a little better. Yeah.
Yeah. So, hello. Sorry, I just totally broke the camera person moment there.
Yeah.
Anyway, so I guess we'll dive into why and how we're doing this talk. Both of them are a little unusual. For the last, I'd say 3 or 4 years, I've come to Devoxx and done like an introduction to Scala session. And one of the things that I've come away with thinking from that is that 3 hours really isn't enough to give a good grasp of Scala. You can get into some interesting stuff and maybe convince people that they might want to go and learn a bit more about it. But any language you're not going to get that far inside of 3 hours with, really. So this time I thought, why not do something, why not choose a feature of the language and concentrate on that, assume no knowledge of Scala coming in, but concentrate on that one so that hopefully it will have something for everybody. People who have not seen Scala before will at least get a taste of what, you know, a single spike through the language looks like. And even people who have used it probably will learn a thing or two about the more advanced use cases for implicits in this one. The reason I chose implicits was I have to give kudos to a member of the Kotlin team whose name slips my mind, but I got into a conversation with one of the Kotlin team Kotlin's a language that JetBrains is developing at Google I/O. And we were talking away, and he was like, what do you think of Kotlin? I said, you know, I think it's very interesting. I would find it difficult to go back to a language now that doesn't have trait linearization was one of the examples I gave. And the second one was some kind of mechanism like implicits that lets me do type classes, which is something we'll get to later, because I use them so much. And he immediately turned around and said, implicits are the devil. And so that's actually the first thing. So I said no shyness here. Hands up anybody who thinks implicits are the devil. Okay, good. There are some people. Anybody not putting their hand up because they're embarrassed? You should put your hand up now and just say implicits are the devil. So hopefully we can convince you, between us, that they're actually not the devil. I think that they're probably a better analogy, I was thinking on the way here, is that they're like a chainsaw. A chainsaw is a very bad thing in the hands of a mass murderer, but it's a pretty good thing when you need to cut down a tree that's blocking your road.
That's true.
And so they're a very, very powerful feature. They just have to be used well. So that's why. And the reason implicits, because I think of all of the features in Scala, it's probably one of the least, or the most misunderstood. I think there's aspects of it that are extremely powerful. There are aspects of it that are extremely dangerous. But the key is that it is an integral and very important part of the language that leads to some very different kind of problem solving. So anything you want to throw in there? Or?
Oh, well, in the case of things that are the devil, just to get a feel for the audience, how many people think NullPointer exceptions are the devil?
Oh,
okay.
I think
all right.
that, yeah.
All right.
I think
Good. We're getting more hands there.
Actually, I think use of any kind of null is the
now,
devil.
How many people think garbage collection is the devil? All right. How many people spend, now I'm raising my hand here, how many people spend almost all of their performance time optimizing the garbage collector? Okay. All right. Maybe it's just me. I'm sorry.
Our approach is just give it an enormous heap size, and then run the process, and then throw it away at the end. So it never has to garbage collect at all then.
That's cool. Well, anyway, no, I love garbage collectors. I think they're a great thing, but I also think they're really hard to tune. I think implicits kind of fall more in line with garbage collection. It's core to Java that there is garbage collection. In Scala, it's core that there are implicits, but there's the same kind of trade-offs as with garbage collection. In C++, you always worry about memory. Always. And in Java, you don't until you start optimizing, and then you care a whole lot, right? So it's kind of the same thing with implicits. You take a piece of things that you're going to kind of ignore until later, and it lifts a lot of gunk from your code that you don't have to think about all the time. So that's handy. Anyway, that was my analogy.
So now we're going to talk about how this, this talk is going to work. A couple of years ago, I went to see, anybody know who Venkat Subramaniam is? Yeah, seen one of his, he does great, he does really good, innovative presentation style. So I decided to completely rip off his approach this time and try it for myself. So he doesn't have any slides. He has a list of points that he wants to make, which is up on the screen. Every time you make a point, you give yourself a little check mark, which feels really good, actually. It's like a little mini reward that you get each time you go through one of these. And it kind of reminds you, but it also keeps it very fluid. This is going to be code heavy. It's hopefully going to be two-way, lots of two-way communication. What we're going to do is we're going to talk about implicits, but assuming no Scala, we're going to introduce the language features that we need along the way in Scala to support what we're talking about. So we won't just talk about a class without showing how a class is defined in Scala, that kind of thing. Now, this is the first time we've done this talk. I think I got them. I think I got the things that we need to introduce. But if you see something unfamiliar, then probably yell out. It's kind of hard to see with the lights here. But if we forget to talk about something, or if you just want clarification on something, just yell out and we'll dig further into that. Okay, and if you can stump us, we'll come up with some kind of...
one of those check marks that make you feel good.
Yeah, we'll add a check mark.
You'll get 2 check marks per stump, yeah.
That sounds good. So introduce features as we go and Venkat style. Check, and check. Right. Okay, so now we're going to look at what. What is an implicit? So has anybody not used Java here? Anyone not used Java in at least some form in the room? Okay, so you've all used implicits then, whether you know it or not. Let me show you something quick, and we'll see what you think of this. So let's take a square function, which takes an x of int. So this, I'm now demonstrating how you define... can you see the red there, by the way? I can change the color scheme if it's good, okay. So I'm going to define a square function, which takes an int and returns an int. And it's just going to multiply x times itself, okay? Actually, let's make it more interesting. Let's do it for a long and a long. Right, so there's a square. That's a definition. That's a method definition in Scala. And now I can say square of 2, and it tells me that it's 4. There's a bit more going on here. This is the REPL, which is the interactive shell. It's very nice to be able to work in Scala. I run it all the time. 5 years in, I still start the REPL all the time to try stuff out. But in this case, there's a few things. First of all, I did specify the return type here, but I could leave that out. So let's leave that out. It still knows that is a method from long to long, so it's inferred the type. That's another thing that you get in Scala for free, is the compiler's quite clever at figuring out the type, so it doesn't make you most of the time, it doesn't make you explicitly add them. One of the exceptions is a method parameter. It has to be there, because otherwise it doesn't know what it's dealing with inside of the method. So you need to give it the type for a method parameter when it's coming in. But most of the time, it can just infer that. If I then say something like a val is like a final variable. So in Java, you've got final. It means it can't be changed after it's been assigned the first time. I could say val I equals 10, let's say. And I don't have to specify a type for that. It knows that it's an int. So now I've got an int. Now, let's also make a long. So val c or l equals 10. Right. So I've got my method definition. Let me make this a bit bigger for a sec here, so you guys can see it. Where's the little?
While Dick's doing that, I want to say the most important thing in software is naming. So if you need good names like I and L,
don't do this.
Come ask us. We got them.
Well, I is for int and L is for long.
I know,
right?
it's cool. I do the same thing.
Bill always busts me for using L because it looks like a 1. So I had a tendency to use L for list. And it did get confusing, so now I use x's whenever I use a list. You just say val, let's show an example of that. Val x's equals list 1, 2, 3, 4, for example. And that gives me a list. There we go. So anyway, we've got our definition, a square, which takes a long, and we've got our value L down here, which should have said,
It looks
that
like
should
an
have been.
int.
Yeah, that is an int because it's happily using an int for that. If I force it to use a long here, which you can always do, you can always explicitly type, L is a long. So if we just put that up there, L is a long of 10. Right. Now I should be able to do this, right? I should be able to invoke. L is a really bad choice, it turns out, because now it looks like I'm doing a square of 1.
It does.
Let me change that. Val lng equals of long.
You should do 10L.
Yeah, that's true. Equals 10L.
Otherwise, you're using implicits already.
That's true.
You're confusing the people.
True. Okay. Ignore the man behind the curtain.
Sorry.
All right, lng is a long. Everybody agrees that I should be able to call square on lng, right? Because it's a long, and the method's expecting a long. And sure enough, that works. Who thinks this will work? I being an int. Anybody think this won't work?
Well,
okay.
And also, anyone think it shouldn't work?
Anyone think it shouldn't work? Yeah, that's an interesting
Because we'll have a philosophical debate later.
Yes.
Okay, save comments for later. Cool.
Okay, so let's see what happens. Sure enough, it works. And it's, well, but that's an int. And the method wanted a long. And we've got a long back. So what's going on there? This works in Java as well, so you kind of expect the behavior. But we just gave it the wrong type. And what Scala did behind the scenes was an implicit conversion. There are implicit conversions defined in Scala. Just like in Java, they're not called implicit conversions. They're just called type widening or value widening
and
or whatever
auto-boxing.
it is. Auto-boxing and all that stuff. But those are implicit conversions that Java's doing for you. The difference here is that in Java, the language designer's got to use those tools, but you don't get to. In Scala, those tools are available for you to use as well. So those, you might think, oh no, that's a special case. No, those are actually implicit conversions that are defined in a package called predef, which is automatically brought in when you use Scala. And so these are actual implicit conversions from an int to a long. If we go the other way, it doesn't work. We can't do def square I, where x is an int, equals x times x. We can't just do square I of long, because that is a type mismatch, okay? It won't go the other way. There's no implicit conversion because it might lose some kind of information. You can put things in a long that you can't put to an int. So you would have to do an explicit conversion in that case. But that's an example of an implicit, and I think it's probably one of the least controversial uses of an implicit conversion that's out there. It's one that people are familiar with.
Except for a few people. So I'm curious.
Yes.
Do we have a good philosophical argument on why you should not automatically convert numeric types? Anyone?
Don't be shy. This is one of the things that's very liberating about using Scala is all the things you think you know, you really don't know that well anymore. And there's a lot of stuff that's open for debate that wasn't for years. Yeah?
So let me try it. Is it because the compiler lets you compile something that shouldn't compile? I mean, the types are incorrect, so what could be a reason?
Yeah, I mean, it is a fair point to make that if you specify a type and somebody uses a different type, you may fairly expect that to not compile. And the exceptions are these widenings that are automatically provided in most languages. They're there for convenience, but I mean, I've had a similar, I had a similar but much worse issue years ago using C, where doubles could, or no, a long could be turned into a double. Was it that way around? Yes, a long could be turned into a double. And I was expecting a double with a very small delta, a point delta, between two sets of coordinates that, so this is a really kind of labored example, but the very small delta was enough to give you a direction for north. It was in a geographical information systems thing. Somebody called it using a long, okay, and the long that they gave, it was the same long, so there was no direction vector to work out. But it didn't give a compile error. It just worked happily, and then north was the wrong direction. And I had to go, looking through lots of code and figuring out, well, okay, that's what it is. You've given me two longs that are the same, and you really need to give me two floats that are slightly different so that, they're not the same coordinate coming in. So, yeah, there are problems. That's about the best example I can think of.
So I think what's happened is, to add in here, double, int, float, boolean, have kind of standard definitions in a lot of languages now. And those are kind of types that you use in that fashion. But if you actually want to enforce constraints in the type system, you make new types, like meter or length, that sort of thing. And you start get back some type safety and use something with a specific name that means something. Yeah, there's a question back here. What was the part that was done at runtime?
Yeah, I'm going to try and summarize the question. So I think your concern is over there being a separation of, when you're using an implicit conversion, of some part of it happening at compile time and then some other part happening at runtime, and the two could be incompatible in some way or contradict one another. Certainly been my experience in Scala that the use of implicits is really to force the compiler to do this kind of thing. By the time you're using a method that's, well, and we're jumping ahead a little bit because we haven't really talked about extension classes and things like that yet. But by the time you've got to the point where an extension method is being used, the compiler has decided for you that is a valid conversion, that it's done, and kind of all of those channels have been laid. So there isn't, that's actually one of the real advantages of using implicits, is you can take a lot of things into compile time that used to have to be done reflectively or dynamically in these languages, and it gives you a much greater level of type safety. I think we're going to get into that, or compile time safety, I should say.
So an example of this is actually numeric widening. There's actually bytecode in the JVM to widen your numerics, to go from int to long. You actually have to write out bytecode to do that. So when Java sees you doing that, it adds this bytecode in there. It's adding code in, the compiler is, that it knows to be safe from the types. That's all Scala does as well. There's just the code can be a custom method you have defined.
Here's actually just jumping ahead a little bit, but I'm trying to find int to long. Int to integer, long to long. These are the pre-defs.
Oh, some of them might have moved to the actual int object.
Yeah, okay. So maybe not the best time to
Yeah, there's also,
demo that, but
if you go back to the REPL, you can do :implicit conversions.
Yeah.
Or implicit.
Conversions, does
I
it?
think it's capital conversions, yeah. Is that what, or just implicits maybe?
Oh, I think it's implicits, yeah.
Yeah.
Oh, no, stop being helpful, Sublime. Stop being helpful to me. Okay, so it actually tells me no implicits have been imported other than those in predef. That's useful, though, when you're working interactively to see what have I brought in, what is it doing. Okay, so that wasn't, sorry.
Oh, no, I was just going to say, I remember there being, when that came in, it was verbose.
Yeah.
So anyway, sorry.
Okay, so that's an example. That's a very simple example of implicit conversions that you've seen, and probably if you've worked with Java for any length of time, you take those for granted. And that's, I think, really the key to a good implicit, is an implicit should be something that's kind of so ubiquitous, at least in some specific context, that actually typing it out every time would just be a pain. So that's when you use an implicit. That's a good kind of yardstick. Is this thing really ubiquitous enough in this setting that I'm working in? Maybe it's a domain-specific language that I'm working in or something like that. But is it that ubiquitous that I just want to be able to use it without having to think of wrapping this thing first or doing some operation to it first or using a parameter that I know is always going to be there? In Arca, for example, which is the actors, well, that's actually a lot more than that, but the actors part of Arca, lots of stuff has a timeout that needs to be specified, because when you're dealing with anything to do with threads, you don't want blocking calls that last forever, because that leads to deadlock and stuff like that. So you have to specify a timeout. And specifying a timeout all the time is a pain in the butt. So what you do is you define an implicit, and all the Arca classes and all the Arca methods know to look for that implicit. So you define it once, and that's your default. You can always change it later, but that's your default. Okay, so that was what is an implicit. Well, that's one part of it anyway. So let's now look at it, how you would do your own implicit conversion. So here we've just done, there's a couple more language concepts I wanted to get in early before we move on, so let's get those in. We've already shown method definition, the fact that the definition that I just did, making a square. I've got another one here that's for a factorial. This factorial uses a fairly simple recursive algorithm just to get the factorial of a number. It also uses something called pattern matching, which is this part at the top here. This is something you'll see a lot in Scala. It's not really key to the talk, but it's cool, so I wanted to throw it in there.
I would say it's one of the best features of Scala.
Yeah.
If you were to name the top 3 things that keep people on Scala, this would be one of them.
The problem is about 30 things in my top 3 things for Scala. Case classes are in there as well.
Well,
and traits.
but case classes are related to pattern matching.
Yeah, that's true.
Anyway, so this is basically switch statements on crack. On the left-hand side, you have a pattern, which is what you're matching against. Okay, and you can also have guard statements. See how there's an if in there. So you can throw any kind of guards you want. You can AND those together. That needs to be something that returns a Boolean. And on the right-hand side is what gets performed. There's no explicit break in Scala. You don't have to write break. It's an implicit break on every statement. So if you want to share, the same behavior for statements, there's like an OR operator between patterns. So you can actually OR a bunch of things together and have the same code, or you can copy paste it if you're like me, because I have terrible code style. But anyway.
So the next thing is going to be, we're going to see class definitions. So very simple class definition. There's a few things going on in this one. This is, in this case, I've created a person. And for the example here, a person can have a superpower, or may have none at all. So there's a few concepts here. First of all, we've got a class of person. That's the definition. The constructor, the primary constructor in Scala, coincides with the definition of the class. So I'm actually providing the constructor parameters that would be taken. So this one takes a name when you create one of these things. And also, this val in front of it means that this thing becomes what's known as a parametric field in the class. So it's public and final. It's public and fixed. So this is somewhat of a value class. It's, the name is pretty transparently available. It's available as .name. So when I create one of these, and I'll show you this in a minute, you can actually type .name and get the name back out. The superpower is just a method that's defined in there. And it uses another concept, which this is another one of my favorite things about Scala right here. Good old option.
Yeah.
Option is, in languages like Java, it's very common to use null when you don't have something there. And after you've used a language where you don't use null for a bit, you come to realize that anytime you see null in the code, that's actually a bug. Okay, null equals bug. So never, never, never use null anymore. Option gives you an alternative that says there's either something here or there isn't. Okay, it's an option of string. It's not a string anymore. If it could have been null before, what I'm going to say now is it's never null. It could just not be there, in which case it's this empty box called none. And if there is something there, you've actually got a sum of that string. So I can show you that quick here. So let's say we have val s1 equals, is of type option string, and we can set that to none, and then val s2 is option of string, let's explicitly type it, equals sum hello. So those are the states that it can be in. It's either got something in it or nothing in it. Now, here's the difference. With if I do ns1 equal, of type string equals null, and val ns2 equals is of type string equals hello. Right. Now here's the evil with nulls. I can say ns2.length, and you get 5. I can say ns1.length, and you get a NullPointer exception. Okay? We've all seen these, I'm sure, many times. Many, many times. I reckon at one point, about a third of the exceptions that I'd see were NullPointer exceptions in running code. And the problem is, the compiler can't catch this for you. Okay? It doesn't know what the state of this thing is ahead of time. All it knows is that when it tries to invoke something on that, there's nothing there for it to do it on.
And we don't want to annotate everything not null.
Right.
The point is to have less typing in general.
So what we have instead is we have S1 and S2. So S1 is our option of string, which is none, and S2 is our option of string that's sum. And now I can't say S2.length anymore. Okay? Because that's a compile error. Length is not a member of the option of string. It's a member of the string. So what we've just done, it's very subtle, but we've taken something that was a runtime error, and we've forced you to deal with it at compile time instead. Okay? Now I know that this thing's an option. Instead of just writing something that assumes it's there, I have to deal with the fact that, hey, it's an option, it might not be there. And there's various ways you can do that. You can do pattern matching on it. So def uppercase, let's say, of s of option string, and I could say here equals, and then I could say, actually let's just do it like this, s match, don't close the curly brace for me, case of none goes to, let's say, empty string, and case of sum x goes to x.to uppercase. Somebody is bound to tell me that that's not the right way to do uppercase because I haven't got a locale in there, right? Very bad programmer, but never mind. And now I can say uppercase S1.
That method doesn't handle Korean, man.
No, it doesn't.
Or what I was trying to say was Klingon.
Oh, Klingon.
I said Korean instead. I'm sorry.
Yeah. So anyway, so that's the difference. Okay, we've just taken something that was a runtime problem, and we forced the programmer to deal with it at compile time. And that's pretty profound. Yeah?
Why did you say that this was the bad case of case matching?
The two lowercase
No,
is bad.
Not the case. The switch or the match statement is fine, I think. It's the two uppercase. I've been told many times that you're never supposed to use two uppercase without defining a locale for the character conversion, because you're assuming we're rich, entitled Westerners that are assuming that everybody speaks English, basically, by doing that.
And that there is an uppercase.
Yeah, and all these other things. That it's just total entitlement. So anyway, yeah, that's why that was bad. So.
Is the set locale of your system the implicit conversion? If you want some other conversion, you have to give it in.
Yes, actually, that's true. I mean, there is a standard locale, isn't there, in
There is
Java?
a standard locale. Yeah, actually, when I write IO internally, that's what I do. But generally, we're still using Java IO, so you're stuck with verbosity.
So that's what we, in the Scala world, and we haven't got there yet, would call an implicit parameter, because that's a definition with a specific type that the system goes to look for when it needs to look up one of those things, and it doesn't know what it is. But we'll get there.
There's a library called Rapture IO. I'm just going to mention it now, and I'll continue to mention it throughout the talk, that heavily uses implicits, and they do that exact thing where the locale is actually an implicit that you pull in, and then the methods will use it if there is one. If not, you have to specify.
Okay, so that's the person. The superpower is an option, and it defaults to none. So most people, myself included, don't have a superpower unless you call knowledge of Doctor Who, like in-depth knowledge of Doctor Who, a superpower.
That's pretty powerful to me.
I think so,
Yeah.
but you can test me on that later if you like. But anyway, in the meantime, I'm going to assume I have no superpower. However, there are certain people who have superpowers.
How many sword fights in the history of Doctor Who?
Oh, there were actually, I don't know the exact number, but I can tell you there were quite a few, because the third Doctor, John Pertwee, he was quite a man of action. And he would actually, pull up a sword and fence somebody or something like that. He was definitely one of the more action-packed Doctors. He liked to drive around in a hover car as well, and lots of good stuff like that. Right, anyway, I digress. So, yes? Yep.
But you solve it using a runtime box instead of inserting this in the type system?
Okay, so I think the question was, or if I can paraphrase, so what I said about option was that you're taking something that was a runtime problem, which is null values, and you're kind of bringing them back into a compile time concern so that you have to get it right at compile time. But then what we're doing is using a pattern match here that actually handles this at runtime. You are correct. There is the pattern match is one way of dealing with this. The key.
Yeah. Yes. So
That's
so the
correct.
answer is option is a box. Yes. Now, there has been talk about turning option not into a box. We have a mechanism in Scala to actually not box classes, to leave them raw. The problem is that some people were writing sum of null
Yes.
to represent, because databases do this. You can actually have a value in a database column and the value is null. So you have to be able to represent it as sum of null. So we actually can't remove the boxing in the compiler safely because of that use case, which is terrible. So there was talk of making another type that's completely not boxed. You're right that you are adding boxing here.
Yeah.
For the most part, when you actually want to have existence or non-existence, this is what you want. There's like, I would say, I actually want to write a blog about the many use cases of null and how only one is viable. Because option is specifically about existence and non-existence. It's not about error handling. It's not about early initialization and that kind of stuff. It's about existence or non-existence. So if you limit it to that, usually it's not that big a deal for overhead. When I have to write highly performant code, it's never bitten me when I use option. It's usually not in that part of the code. Yes?
I've got another question. Can you go back to this pattern matching with option?
Yes.
Yeah. Why do you use pattern matching instead of using for, which is more idiomatic?
I was just going to show actually map as a.
You violate what Scala provides, you know.
The reason. Okay. So the question was, why did I show you pattern matching rather than one of the other alternatives that you have? In fact, the most idiomatic way to use an option in Scala is to use a for comprehension on it. And that gets into a whole area that we're dangerously close to the M word at this point.
Yeah.
Actually, I wasn't speaking about for comprehension. I was speaking about fold.
Right. Okay, so fold, yeah.
On option.
So fold on option.
Oh, fold. Okay, there's a very important reason not to use fold on option. It's not very important. It's relatively important, but it's actually it's optimization. So pattern matching actually under the scenes is implemented as option and is able to unbox all the options and get you highly performant code. Fold, you're actually constructing two function objects that you have to pass down in, and only one of them gets used. And the JVM currently has issues optimizing that. I'm hoping with Java 8 and with some new bytecode generation that'll go away. But right now, preferring pattern matching over fold is a performance-related thing. Honestly, like I like fold a little bit better myself, elegance-wise, but I still use pattern matching.
I actually tend to use, for option in particular, rather than using fold, the way that I tend to do it is, actually mostly is a for, because fors are really very pretty when you use them. But you can also map a function over the option. So here's an example of that. This is a slightly more compact way of doing what we just did. You can say S1, which is the option, map x, and this is a function literal, so I haven't shown these yet. This is a good chance to show function literals. Also known as lambdas in Java. They're coming in Java 8. The difference is that they use a single dash in their arrow, so totally different. But other than that, looks very similar. But what this basically means is this is a function literal, or an anonymous function, that takes x and converts it to x to uppercase. But if you run this on a none, you still get a none. If you run it on something with something contained in it, a string contained in it, then you get not the string uppercase, but an option of the string uppercase, the sum again. So it's mapping the function over the contents of that thing. And as a very rough analogy, you have to be careful with this one, but as a very rough analogy, you can think of option as a list of 0 or 1 things, a list of maximum 1 length. So if you think of it like that, then when you map a function over a list, you expect it to do that same function over all of the items in a list. If you map it over an option, and you've got nothing in it to start with, you end up with nothing in it. But if you map it over an option with something in it, you end up with another option with the mapped item in it. Okay, and we've just dealt with function literals as well, which is great. So we're motoring through we're absolutely motoring through. Everybody's going to leave this an expert on Scala.
Anybody not understand functional literals? Let's have a raise of hands. More on that. More on pattern matching. Anyone?
Well, there's lots of pattern matching.
What about more on implicits? Are you guys done? I mean, all right.
Is that it? Okay, we're
Awesome.
going to keep going with implicits then. That sounds good. All right, so, yes, I hadn't quite finished my talk through. So another quick thing we'll show, this is not really important, but it's the new way of doing things. Scala has string interpolation as of Scala 2.10. It was added, right? Which just means that you can do things like this. So you can say, we've now got a person of type, a P of type person. We know that person has a parametric field called name that we can access. So what I can do is I can stick an S in front of the string that I'm creating and a dollar and curly braces, and then I can say p.name, and that will get substituted into the string for me when I do that. And I could have also put this whole statement in, but I thought when I did that, it actually obscured what the statement was doing. So I went to give you a bit more of a Scala feel by not putting that inside of the string interpolation. But this whole thing could happily go in one of those constructs as well. But what I'm doing here is I'm saying the person's superpower, much like we just saw. So you say person name has, and then you say person superpower map, and the superpower goes to either superpower colon and that superpower, or, and then this is the get or else, so this is another thing that's available on option. What get or else does is says, if there's something in the box, use that, or else fall back on this other default. Very convenient, and again, compile time verifiable, so we don't end up with a null coming up in a string or something like that. We have to deal with the fact that it may not be there. So what this will say is, in this case, where I define Dick Wall down below it, a new person of Dick Wall, then if I say person details on that, this function will print up Dick Wall has no superpowers. Wah, wah, wah. But, and then the final part of things that we're going to see as we go through this, Scala also has this, oh yeah, sorry, I see a hand.
Go back to this
Get or else, yes, okay.
I might be mistaken, but I've been hearing that get or else accepts any type. So you can actually assign any type inside this get or else, meaning that you can pass the compiler and get some weird, nasty.
Well, yeah, but you won't make it out of the compiler here.
Go ahead.
Yeah,
You may want to repeat the question.
So the question is about get or else. You can pass any type to get or else. That is true. That was part of the question. The question then is, if I pass something weird to get or else, aren't I going to make it past the compiler and have all sorts of explosions? Yeah. So if I want a string here and I have result 14, right? Which I need an equal.
You do need an equals.
Result 14, and how do I scroll up on this guy?
Yeah, you were right. Yeah, it's reversed. It's
It is
reversed.
It's reversed from the reverse.
Yeah, it's the way that it's
All right.
been for 20 years until
Okay.
Apple decided it was the wrong way around.
So we know that result 14 there is an option of string, right? So if I get or else with a string, what am I going to get back? A string.
Right.
But if I get or else and I throw an int in there, it's actually going to tell me, hey, you passed in something that was an int, but I need it to be a string. So that's not good. But and why does that work? We're going to talk a little bit more about this later with some type constraints. But it's going to try to find the common supertype between the right-hand side and the left-hand side. So what's in the option and what you pass it, and it's going to return the supertype of that thing, which in this case is an any, and you ask for a string. However, the type checker in this case, because we're forcing it to be a string on that X, knows that you want a string and is constraining the type on the right-hand side to be a string.
Oh, I was going to say,
Now,
yeah, if you
if we
get rid
take
of the
this
type
out,
constraint, yeah.
So, right, in that example right there, we got the best possible error message. Here we're just going to get a weird-looking error message in a sense. What is X? Is X a string? Can I pass it to a method that's a string? Oh, what happened? What did I do?
Oh, you made it big.
Oh, I'm sorry.
Oh, that's okay. Yes, there we go. Sorry, it's yeah. Don't make it big.
Okay.
That's the real estate.
I
You've
will
got
not
to work
touch
with.
the computer from now on. I'll stay over
No,
here.
no. You can touch it. Just
Okay, all right. So
everybody's patiently waiting
Yeah,
to tell us that they're not
because-
seeing a damn thing that we're doing here.
So I don't know how far back I have to go there, but yeah. So in the first case, we got that, we found an int, but we knew we needed a string because you requested a string, and we constrained it to know that this had to be a string on the right-hand side. Here, it looks for the common supertype between string and int, and what does it return? What is X? Any.
Any.
Yeah. What is any? Any is, that's Scala's top type. That's
The
kind of
toppest.
like Java lang object, but even higher.
It's toppiest of tops.
It's topper than the, yeah. It's topper from Dilbert, basically. He's always above you.
Yep.
Anyway, so can I pass that to something that expects a string, an any? No, you can't. If you have, and I'm going to call something foo because that's my name. That's what I do.
That's how you roll, man.
Yeah, and foo is just going to return, I should just call it identity. But if I try to pass this any, what was the name of that sucker?
X.
Okay, by the way, if you guys need names, just ask. We are.
Yeah, we got all the names.
We
We got
got
about
the names.
26 of them.
Yeah.
Actually,
+3, foo, bar, and baz.
yeah.
It's 29.
52 if you count
52?
uppercase.
Oh, okay.
Yeah.
But we always do lowercase, don't we?
Yeah.
All right. So, yeah, here you'll see we passed in any required a string, right? Any is the top level type, but if you have a type below it, the compiler's not going to automatically downcast for you.
Yeah.
In fact, this is another example of implicity things happening, but it's a totally different mechanism. But anyway, okay, so you can't pass an any to something that requires a string. So even though get or else can take anything on the right-hand side, it's going to figure out this type constraint for you and guarantee that all the types line up correctly. So if I'm passing it to something that takes an any, say a logger, I can do get or else 5, and that's fine, because a logger is expecting an any. It's going to just take it and call toString on it. Cool. But if I'm passing to something that expects a string, I would have to put a string on the get or else. It'll constrain me.
Yeah.
Does that help?
The short answer to that is, well, with some notable exceptions that occasionally show up as very rare bugs, you won't fool the Scala type system. It's pretty good. It's good at figuring out the constraints.
And if you need to fool it, I can help you out, but the types are kind of incomprehensible.
Yes.
Yeah.
How does this get or else relate to this map with default?
How does the get or
Map
else
with-
map with default?
So the question is, how does get or else relate to map with default? And map with default is defined on option. I believe if you were to map with default an identity function, like x just returns x, and then a default value, it's kind of the same.
Yeah. Okay. So, right, the last of the new concepts that we'll need in this next bit is there is this other feature that Scala has. So Java has statics, which are a place that you can put methods that are kind of available from the class rather than the instance level. Okay, so static methods, fairly common thing to want to use. Scala doesn't have statics, but what Scala does instead is it brings in a concept which was very, very popular a few years ago when the Gang of 4 books came out, which is the singleton pattern, where you have a single instance.
How many people think the singleton pattern is the devil? Rock on.
And actually, you do have to be careful with objects because they can the singleton pattern leads to something known as static cling when you start using it heavily. It means that you've only got one way to wire up your entire system, and it kind of prevents you from doing anything else clever with it later, particularly with testing. And you can get into the same sort of situation with objects if you're not careful. But objects are a more elegant solution to the same sort of problem. So
the key too, I think, with objects is generally you're not encoding state in a lot of Scala's singletons, and objects can be in any scope. So here's an interesting Scala-ism. I think Dick is showing here how to create an object. I'm going to show you how to return. What's a good interface we can implement quickly? Maybe a runnable.
yeah,
And this is going to be called foo. If you guys have a new name,
Oh,
you can tell me. But
you've now got a sad face
I like
upside down.
smiling men. Runnable, or not.
Oh.
No, stop.
It's because you're touching the touchpad.
Oh, am I?
Yeah.
I got fat hands, man. Okay,
It's
so
one of the other quirky things about my computer.
here's a fun thing about Scala. Inside of any scope,
Here.
oh,
This will help.
if
If you put that up there, then now if you press the
now it won't.
touchpad, it won't actually mess you
Oh.
up.
Fun. Okay. Inside of here, I can make a new object. Runner extends.
Oh, what did you do?
I don't
You
know
made a
what I
big
did.
screen again. What are
did I
you
do?
doing?
I'm just typing.
Okay.
This is yeah. What program is this? This is the Josh Sucks program. This.
Do you want me to type in
Yeah,
instead?
yeah.
Okay.
So we can inside of here make an object that extends runnable, and this creates a
But it's
class
def run,
and an
isn't it?
instance at the same time.
Is it a unit?
Yeah, it returns unit. It might need parentheses. I don't know. Just println hi. I don't know.
println. Hello.
Oh, and it needs to extend runnable actually.
Oh.
Yeah, we got to start again.
You type 2 lines. But by the way, that's one of the best tips you can get out of this is if you get stuck, press return twice and it gets you out of all of these things. Until you know that the first time, you're like, damn it, give me my
one more n.
runnable.
Yeah.
Not runsable.
So So
That's
you
a
can define
spoon.
one of these in any scope, but what it does is it creates an instance of a class. You're defining the class at the same time you're defining the instance. And then you can, you need to return it. You
Oh.
actually,
Yeah.
yeah.
Damn it.
'Cause
My wonderful demo.
we're going to type it a fifth time, and fifth time is the charm, I hear. Anyway, so we're constructing this class here, and the compiler is actually going to create a class for you called runner, but it's going to have some funny gunk in front of it to represent what the scope is, and then it's going to instantiate it in this scope, and you can actually
Fifth time is the
capture
charm.
things. What?
Fifth time is the charm.
What did we call it?
I returned run
Instead of
instead
runner.
of runner.
Yeah.
Because, okay.
Okay.
That one, and then runner.
We're going to return it. All right.
Hooray!
There we go.
Thank you, everybody. Right.
Now,
Let's go get a beer.
foo.run. There we go. Cool. So we are constructing this class, and the class can capture variables and stuff. So if I pass something to this method, if I need to define an object to pass on to other things, I can do so real elegantly right there, or I can have it at the top level. If it's at the top level, it's a singleton in the sense that there's only one instance in the whole program. But object is a more generic thing than just singletons, right? It's a singleton in that particular scope. It's an instance of a class where you define the class and the instance at the same time.
Yeah, and I wanted to demonstrate that. So this example I've created two superheroes now, Flash and Superman. Flash's name is Bartholomew Henry Allen. Did anybody know that? A bit of trivia there. And Superman, of course, is Clark Kent. Flash's superpower is super speed, which I was thinking the other day is kind of a lame superpower. I mean, you can run everywhere really fast, but you can't really do anything when you get there that's particularly, I'm here, but I'm about to get crushed by the falling truck or whatever.
No, putting tax on people's seats and stuff. That's he's the trickster Superman.
Okay, yeah. And then Superman, of course, can do pretty much anything.
But isn't his name like Kal-El or something?
Well, actually, that's true.
You don't have two names available.
It should have been the
Our
alias.
abstraction is wrong. Sorry, guys.
Okay, but anyway, the point is, if I now run this, so I'm loading this into the REPL. Now what I can say is I can say person. Oh, wrong one. I can say person details, and I can say Dick Wall, which is a value. Okay, this is this new instance. This is an instance of the class, of the person class. And that works. It says Dick Wall has no superpowers. I can also say person details of Flash. And that's the object. So the key here is that Flash is simultaneously a definition and the only instance of that thing. Okay, the universal instance of that thing. Once you get the idea of that, that's pretty cool. So Flash is actually a person because it extends person. It's the only instance of that. It is that, the Flash. And I can also assign it. I can say val p1 equals, of type person, equals Flash. And that's fine. It's just a value. That's the point, is the Flash is the instance as well as the definition of that thing. Right, why we did all of that is so that we can actually talk about, you can't do a new Flash. Let's try it.
So there is a class for Flash,
Right.
but you don't have access to it because you want it to be an object. You want a single instance of it, right? So the only way to create Flash is to hit that block of code, and then Flash is created.
It really is a true singleton.
Yeah.
Okay, so what can we do with all this now that we've introduced all these concepts? Why the hell did I go to all that trouble? Okay, so let's have a look at an implicit conversion that we might actually want to use, where we've created a rational number. So this is a rational number class, which is, a fraction like you used to write in school, like 1 over 2, a half, or 2 over 3, 2/3.
We should limit them from going over 100 so that we can do the math in our heads.
Yeah, that's true. There's a few things here that I'm going to throw in on the way. I never thought we would have enough material, and it turns out we're not going to get through all of it anyway, so we'll just party on and keep going. All right, so here's our definition. Here's our class definition. Remember I said the constructor is part of the definition. It's part of the class, the class declaration here. And there's a numerator and a denominator. This is a case class, which we haven't talked about yet. For now, you can think of them as kind of best practice value classes. They have fields of parametric and vals, so final by default. You can access them. They have an equals and a hash code and a toString generated on them. I've actually overridden the toString here, but you don't have to do that.
You don't have to do Control-S to do that.
That's
for
right.
Eclipse users.
That's the yes.
Yeah.
The equals really works, and the hash code really works, and you get all that stuff for free. You also get various things that let these things get used in pattern matches, which is very cool. And that's why they're called case classes, because they can be used in case with case statements in pattern matching. I've got my override here. Another thing about Scala that I'll see, there are a lot of things that we actually cover when we go through this. Override is a keyword in Scala. It's not an annotation, and it has to be there. If you're actually overriding a method, if you're hiding one method definition with another one, you have to have it, otherwise it's a compile error. So it's not just an error if it's not there, and it's not just an error if it's there and it shouldn't have been. It's an error if it's not there and it actually is hiding something. So that's a bit stricter and also saves you some head scratching at compile time. Yeah.
I might be sidetracking a little bit, but you said the case is statement. But is it a statement or
Case, so the question is this case a statement? Case is a keyword. It's used inside of match statements, or match expressions, I should say.
Yeah.
Scala's not big on statements because it's a functional language.
We call the left-hand side of the pattern, we call that a case statement. Like this is the thing that happens and then there's an expression on the right-hand side, and there's a case statement.
Yeah.
So it's called a case statement because that left-hand side doesn't it's logic or whatever, but you can't. Yeah. If that helps. So the terminology can get odd.
Yeah.
Yeah.
So here's the that's the toString definition. Down here, I threw this in there because I thought we might need filler to talk about if it was going to be quick. I'm not going to get into this right now because you don't need to know it for implicits, but just annotation tail rec just means that this thing can be verified by the compiler that it is tail recursive, and that's a nice little performance.
That'll compile to a while loop.
Yeah, internally.
One you didn't have to write.
This is just getting the greatest common denominator of two numbers. So when you multiply, or when you add two fractions together, you often get something like 4 over 12, which you should be able to work out is the same as 1 over 3. Calculating the GCD and then dividing the numerator and the denominator by those simplifies a fraction from 4 over 12 to a third. So that's why we're doing that. The reduce method is what does that. It gets the greatest common denominator. It creates a new rational number. And this is something you'll see time and again as well. I do have to take these asides because I think it's important. It's discouraged and rare in Scala to see state that changes within an instance of a class, okay? It's much more common in functional languages to just take an existing immutable instance and, change something about it and then hand back a completely new instance with the new state in it. The old one is left alone and the new one has the new state. So we don't give back, when we add something to the rational, we don't actually change the original rational. We hand back a new rational number.
So how many people think operator overloading is the devil? It's okay to raise your hand. It's fine.
Yeah.
I would say that about 60 to 70% of the argument against it is because a lot of people were using it without immutable classes.
Yeah. Makes a big difference when you actually do it with immutability. So this is just giving us back. So when we pass in any rational number that can be simplified, it leaves the original alone, but it gives us back a new one that is the simplified. So if you start with 4 over 12, you still have 4 over 12 in A, but if you say B equals 4 over 12 dot reduce, then you get back a new instance. B has 1/3 in it instead. And then operator overloading. Thank you, Josh. I like to point out at this point that technically it is largely a technical distinction, but technically Scala doesn't have operator overloading. Okay, what it has is it has two things. Actually, I'll show you those quickly. it has two things that combine to give you the illusion of operator overloading. So one of them is this idea of infix method calling, or infix methods. So let's say I've got a string, so val str equals hello. I can say str.char@, let's choose 1 because that should be E, I think. Okay, so we've got str.char@1. Now Scala just has this rule that says whenever you've got some item, an instance, say, followed by a method, followed by a single parameter, then you can drop the dots and the parens. So you can just say str.char@, not chat@, char@, and then 1. And that works. Okay, that's called infix calling. It's just a style thing. And that's kind of universal. As long as you got item, method, parameter, single parameter, you can use infix style. Yes? The question is it now discouraged? No, it's not discouraged, but it should be used with taste, as many of these things should. So this is an interesting philosophical debate. In Java, you really only have one way to do anything at all. So style doesn't really enter into it because it either works or it doesn't. In Scala, you've got a lot of the reins have been taken off, a lot of the constraints have been taken off. And what you end up with instead is a language that rewards good taste and punishes bad taste very, very harshly. So in this case, I would not use char@ in this way. I don't think it makes any sense to use it.
What?
In this, you would use char@ like that? Really?
I might, yeah.
I would always do that for.
So I actually, my style is to get.
Even easier, just remove this char@ and just treat string as a sequence.
Yeah, just use apply.
Oh, that's true. Yeah, you could have. Yeah.
Yeah.
Well, that's a whole other rule,
Yeah,
and
but-
we could get into that one as well.
I
but
might actually write apply.
Yeah.
'Cause that would be really confusing.
yeah.
Anyway, I actually, in my code, I tend to have a lot of operator notation, but it's usually human-readable method names. So it'd be like, list filter not, is person in desired city, right? Or in, like, Pittsburgh. And then I would find all the people in Pittsburgh, something like that. And so if you name your methods well, you end up with like really readable blocks of code that you can dig into different pieces really easily. And there's not a lot of gunk, lots of parentheses to figure out. When you put parentheses, you're actually forcing precedence. So I want these two methods to run first, as opposed to, I have to put ... and then parenthesis the whole thing again, and you have just a lot of stuff taking away from your ability to read the code. So I like to write code as close to English, or like hopefully what people would see as possible. So you kind of get a feel for that. Yes?
Parentheses can make scope more visible.
That's true. So the point is parentheses can make scope more visible, and that's doubly true for Scala, where, again, learn Scala because there's this wonderful wealth of stuff that you can never stop learning. It's wonderful.
Yeah, so I always parenthesize when scope matters.
Yes.
If scope does not matter, then you can get away with no parentheses. But when scope matters, the only thing you should parenthesize is the piece that has to be higher precedence.
Yes.
So
About underscore, you sometimes need to do, because otherwise you will get theta expansion.
so I also try to avoid underscore.
Yes.
Now that's another trick, and that's where you can define helper methods inside of your method that you use instead of a function.
Yeah.
That's a beautiful trick. You end up with nice, elegant looking code. And that method name that you give for the anonymous function is a useful method name. It shows up in your debugger, it shows up in your stack trace, and it can help the whole line read better. So I definitely recommend that technique.
So hold that thought.
Okay.
I'm going to just so the complementary side of that duality of infix is that when you call a plus method on something, you're actually, like when you do string plus string, something like that, you're actually calling a method that's just called plus. It's plus as in the symbol. And you can call that in the non-infix way. So this is what you're used to seeing. I don't think anybody would disagree that this is a pretty good use of infix notation. Okay, it looks very natural. It's what you would want to see. But what's actually going on behind the scenes here is it's doing this. It's actually saying hello dot plus. It's invoking a method with the symbolic name of plus on that parameter, on that there. And so what Scala does is it combines infix notation with symbolic method names to give you something that looks like operators. And this is particularly nice if anybody's ever done any work with big decimal. You know how horrible it is when you have to type .add 5, .mult, and all those things. An equation looks incredibly tortured in big decimal. And in Scala, it looks very natural because you just use the operators that you're used to using. So, okay, so in this...
There's a question
Oh.
up here.
In Java, if you write something like null plus there, it prints null plus null there.
Null plus there, like this. Right. In Scala, that won't work because the plus method is not defined on null.
It's defined
Okay.
on every other type
Yes.
except for null and nothing.
What would happen if you change the there plus null?
This is the great thing about
Wait.
the...
Wait, let's take a vote. What do you think would happen?
yeah, before I hit...
No, I really don't know.
Okay. Anyone know? What? It'll work. Yeah.
It will work.
Yeah.
It does... in this case, it does a two-string
so
on it.
anyone want to know why it works?
Oh, sorry, I just gave away the answer, I think.
No, well, I think it does do a two-string because I think the plus
Yeah.
takes an any on the right-hand side. But the one of the reasons why null doesn't work on the left-hand side is it's a bottom type, which means that so string you can pass a null to a string, right? You can pass a null to a person. You can assign a person as null because it's a reference, but so null has to be a subclass of person, and null has to be a subclass of string. Okay? But you can't have multiple inheritance between those two things. So it's called a bottom type because null is like this special thing that extends every class in existence.
Yeah. If you think of the type hierarchy as fanning out from any and then anyref in particular. Anyref is the analog to object. It means any class that extends, that is defined in the system, that you define in the system. There's this other thing that Scala has, partly because Java has these primitives called AnyVal, which represent all of the things that would be primitive in the Java language, so int and long and things like that. But anyref is this kind of side of the hierarchy, if you're looking at it like that. All of your definitions of classes come under anyref in various hierarchies, and they kind of fan out. And then you can think of it as though at the bottom of all those, null is at the bottom, and they all fan back in to null from anyref. Okay? It's
a weird concept.
Yeah, it is a weird concept.
That's a big digression, though. Yeah.
Yes. So anyway, this is the plus method for a rational. We take another rational, we return a rational, and again, what we do is we create a new rational. Another thing a case class gives you is a factory method, so you can just skip putting new in front of it. So we just create a new instance of rational, and we do the math that does that n times that dot d plus that dot n times d, and then d times that dot d, and then we do a dot reduce on it so that we get the simpler form. So let's see this actually in use. This is all leading up to an actual implicit definition, or an implicit example, I promise. So if I say val half equals rational 1, 2, that's a half, and val, let's do 5 halves equals rational 5 over 2. Okay, now I can say, I don't know why I did 5 halves, but never mind. Half plus 5 halve. And it gives us 3 over 1. Okay, so what it did there was it did the math. It would have come out with something else. If I hadn't done the dot reduce, it would have come out with, I don't know, something like 12 over 4, I think, or something like that. But then at the end of it all, it does the reduce and it figures out and it gives you, well, this is 3, or 3 over 1.
Yes.
Someone say, so the slash, when it means division, is just a method call as well.
Yeah. So the question is, the slash when it means division is just a method call. Yes.
Yes.
So then, if you were feeling adventurous, you could then go in and redefine that to combine those two in a rational number, so you could actually just write out the fraction.
Well, no, it's
Oh, no, this is just that, sorry, the slash that you're seeing there is just part of a 2 string.
No, I understand, but
Oh.
Right. So.
conceivably do that to make it work like that.
Oh.
Yeah, the difference though is there's already a slash defined on int, and we'll talk about this later, but that's one of the limitations of implicits, is you can't use them to override existing methods.
Right.
They're not, you're not overriding a method. What you're saying is, if you can't find a method, I'm going to give you one. It's a different thought concept, but we'll get into that in a sec.
All right. So another thing we've got here is, and we haven't seen this yet, but this, I said earlier that the constructor of a class coincides with the declaration of that class in Scala. So here's this is what we call the primary constructor of it, and it takes a numerator and a denominator, and that's how rational. So I could say rational, as I did here, rational 1, 2, and that comes in as 1 as the numerator, 2 as the denominator. I also want the ability to just create, like, any number, any integer, like 5, is also the rational 5 over 1. Okay, that's how we represent those. So I want to be able to say rational of 5. Did I not? I've defined it. Oh, but it's not an apply method, so I actually have to say new on this one. That's right. If I was doing this right, I'd actually add a factory method that gave me the same notation, so I didn't have to do new. But in this case, I'm just creating a new instance of a rational with the value 5 in it, and that gives me back a rational of 5 over 1. And that's this guy right here. It's called an auxiliary constructor, and when you define these, you define them with the method name this. Okay, so this is how you define an extra constructor if you need one. And so in this case, this one just takes an int,
What, so
and it has to be defined in terms of another constructor.
what about using a default instead of that?
You could use a default instead of that.
But then
so
we couldn't talk about this.
Yeah. I wanted to show you how you do auxiliary constructors. We could just as easily have done this instead. This is also a very nice concept.
And this is more, I would say, idiomatic Scala.
Yeah, you'd see this more.
You do not make multiple methods. You create one method that has defaults.
Right.
Same with your constructor.
And now I can actually say rational 5 because the factory method has been updated for that as well. So I can also say new in front of all of these if I choose to. There's still a constructor there. This is just a convenient factory method. All right. So now we've got plus, but plus takes a rational.
We have another question.
Oh, yeah.
So
I've got another question. Since we are at implicits, can we have a constructor with implicits?
Yes, you can have a constructor with implicits. And you can have a constructor with implicit parameters.
You can define. So this is interesting.
We haven't got.
We're going to get into it.
Yeah, we haven't got as far as implicit parameters
Can we hold
yet.
for that? Yeah.
But yes, the quick answer is yes, and
Yes,
we'll get there.
You can put implicit in front of class. Yeah.
Yeah. Okay, so a new. So now we've got I need to create new halves. Anybody know? Quick pop quiz to see who's still awake. Anybody know why I'm creating a new half here, even though I had one before? I guess that was tough. Oh yeah. Yes, that's right. So I reloaded when I changed the class definition. I reloaded it, but my old half is still pointing at the old one. So I want to make sure I'm running the.
So it's actually a
latest.
different class, a
There we
different
go.
type, and things will puke.
So I can say half plus a third, and that works. Oh, look at that. It's 1 over 1. No, that can't be right, can it?
No. What? Oh, a third is a half, though.
Oh,
Yeah. It's cool. It's a lie.
Oh,
the
dear.
names are a lie.
yes.
We,
See, this
we
is
were
why-
doing better with A and B. I mean,
This is why there's no problem with. I was going to say that really threw me for a second there. I'm like, quick, tango on. Do you think they've noticed? Yeah, that was funny. So let's try that again. Half plus a third. This is why I personally use that as an example of why there's nothing wrong with operator overloading, because you can screw people up by giving bad names to things just as easily as you can by using the wrong operator name for something. So anyway, half plus a third gives you 5/6. That's good. What about if I say half plus 1? Anyone? Yeah? It won't work. You got a compile error because I've told it how to add a rational, but I haven't told it how to add an int. Okay? One of the things I could do here is I could define a method like this. I'm going to do it quick rather than demo everything, but I could define I of int, and I could just say equals plus and then rational. If I was making it clear, I'd probably
Or
say
you could
this
do,
plus.
yeah.
Or I could even say,
You could do this space plus, because that's a...
or
that looks
just
cool.
rational of I plus this. Ah, so I could do that, okay? And that will work. Now, anybody see what the problem is with that, if I do that? What doesn't it give me? Yes?
What about longs? What about
Oh, well, that's definitely one. So definitely, what about adding longs and things? But what about if I want to say 1 plus a half? Okay, that's a trickier one. I can't very well open up an int and stick the ability to add a rational onto it. It would be kind of cool if I can, and in Ruby you can. You can, isn't it Ruby? You can just kind of go in and say, hey, int, I want to teach you about my class, so I'm just going to make you work with it. Which is kind of powerful, and also, if you think implicits are dangerous, my God, that's dangerous. So, yeah, you could do that, but here's another option. So what we can do instead, have I got a paste at the top of this? No. This is something else that's just sort of a paste. So that paste at the top just means now to the REPL, treat this whole thing as one chunk of stuff rather than trying to eagerly figure it out. Treat it as one chunk. And now I'm going to add something called a companion object. Okay, and all a companion object is just an object with the same name as a class in the same file. And it has a few things that are special about it. In particular, they're very good friends, and they can access each other's privates, which always gets a good giggle. Okay, so they're kind of like friends,
Well,
friend classes.
Yeah, they access each other's private parts.
Private parts, even better, yes.
That's
And they also...
private members, yeah. And protected members.
There's also part of the nature of a companion object is when you import the class, anything that's inside of the companion object also gets brought along. Okay, that's just something you get. And this is a good place to put an implicit definition because it'll get imported when you import rational. We'll actually get this implicit. So all of this has been leading up to this implicit conversion that I'm now going to do, where I'm going to say an implicit def of int to rational, and I'm going to say I of int. It gives back a rational. I personally, I don't know if you agree with this or not, I always explicitly type my implicits
Yes.
because
Well,
you don't want to screw up on this one, okay? This is quite powerful, and you really want to make sure you know the type signatures that it's dealing with. So I've got this. Actually, the name here doesn't matter. You'd call it something that makes sense to somebody reading your code. I could call it flubar if I wanted to. It would still work. What matters is this method takes an int and returns a rational. And then here I just say equals rational of I. And that's an implicit conversion. So we just defined something just like int to long, which Scala has in predef. We just did the same thing with int to rational. Right, so now let's, I may still have to import this in the REPL, I'm not sure. Can you remember what the rules are? Will it actually get the...
I don't, so it'll pull it in if it's looking for it as parts of the type, but I think you're actually going to have to import it in.
Yeah, so this is a little, what I just told you about putting the implicit in the companion object, that works if you're actually writing this stuff to work in a compiler. The REPL has just a few little quirks that are a little bit different. So what I'm going to do is what the Scala compiler would actually do for me in this case, which is import that implicit. So I'm just going to say import rational dot underscore. That just brings in the contents of that. Right, now I can say val half equals rational 1 over 2. And now I can say 1 plus a half. Okay? Let's make sure it works first before I talk about it. Make sure I did get it right. It works. And what's happening?
Do colon implicits.
Oh,
even
and
better.
colon implicits.
It'll show up.
Yes. There
Look,
it is.
there it is.
There's my implicit. One implicit member's important. Oh, that's... Well, how long has it had the comments there that tell you where they came from? Is that new?
Magic? I don't know.
Yeah, that's... I haven't
We'll
seen...
have to thank Paul.
It's
man.
always fun doing these things because stuff shows up in here that you didn't know. And all of a sudden you're like, oh, that's nice. That's new. I haven't seen that before.
Your previous example was half plus 1, but okay.
No, that's... No, what I was talking about before was half plus 1 would work because I can define a method for plus that takes an int on rational. But the problem was going to be the other way around. However, you bring up a very good point. So let me talk about very quickly about the
actually-
mechanism that's happening here.
Yeah,
Well,
half plus 1 would work without the import.
right.
But 1 plus half requires the import. But we'll-
Interesting. Yeah.
Again,
We'll get into... Okay, so
anyway.
what's happening here when you type this, 1 plus a half, is you get a compile error, first off. Okay, the typer looks at this and goes, no, that doesn't work. No, I can't do that. But then Scala has this get out of this pressure release valve, and it says, well, okay, it did fail the typer, but is there anything implicitly available that would make this work? And so this is the point at which it says, well, I got a type error. I can now look through my list of implicits, and I'll see if there's something that would make this compile. And what it's looking for is either something that knows how to add, how to convert rational into something that it can add to an int, or how to convert int into something that it can add to a rational. Or actually, what it's actually looking for in this case is something that has a plus method that knows how to add a rational. So what it does is it looks through the implicits and it says, there's this int to rational. That gives me back a rational. A rational has a plus method that takes a rational. I'm sold. I'm done. Okay, so it does this implicit conversion. So what it's actually doing behind the scenes is saying int to rational of 1 plus a half. But it does that implicit wrapper for you. Okay, it does that implicit conversion for you, yes. So what if both of the implicit wrappers, I don't know what the second one you're talking about is, but if you're asking what if there are multiple implicits that could apply, is that the question? Oh, right. Okay, so yes, that's the question is what happens if... The larger question here is what happens if multiple implicits can solve the problem? And in that case, Scala's general rule, there are some slightly complicated exceptions around the edges to make some of the subtyping things work. But the primary one is if 2 implicits could solve the problem, it won't apply either of them. It will give you a compile error, and usually it spits out the implicits that could have applied to kind of show you what the problem is. It's known as ambiguous or ambiguity, and it won't use either of them. It's a compile error at that
You have
point.
to pick one.
Yes.
We had implicit def of rational to float. Would not compile.
If you had an implicit def of rational to float, it would not compile. And we can try it. I've never tried. That's an interesting one. Let's give it a go. Actually, let's just do it here, because I can define an implicit. So implicit def rational to float. That takes an R of rational. Returns, let's call it double. I don't use floats. It just feels wrong. Sorry, I'm a bit OCD like that.
So I actually think my guess is that precedence-wise, this is going to be too low.
So let's just do R dot numerator dot to double over R dot D. That should be good enough to do it. That's our rational. Now, okay, the feature warnings we'll talk about in just a second here, the fact that we did that. Now if we, okay, I'm going to create a new half just in case. Val, it shouldn't matter. So 1 plus a half now. Now that still works. Actually, that That's interesting.
It now takes the double. Yeah.
Yeah.
So here's what's happening is the method exists, right? There is a plus method. So the first thing the compiler tries is to take that right-hand argument and see if it can convert it.
Yeah.
And if that works, we're done. It doesn't go into the further expansion because that's actually really expensive. So then after it determines that it can't convert this guy into the type that's needed, a type that's needed, then it goes and looks for conversions from int to other classes that have plus methods, which I think, that's a bit more risky of a proposition or more expensive computation. So that's how it works. Because int has a plus method, it prefers that plus method always. That has higher precedence on the lookup rules. So when we said if there's ambiguous, it pukes. If it's ambiguous within the precedence orderings, and we can go. There's a list of those.
Now here's how you work. If you find yourself in that situation, this is why it's often good, even though Scala has type inferencing, it's often good to put types on there explicitly anyway. I never bust people for putting explicit types on things because you damn well know it's correct then. If you wanted that to work, you would actually say val x of type rational equals 1 plus a half. Now it won't use that other one because it doesn't give back the right type. Okay? What it does instead is it says, no, that doesn't work. I'll look for another one. Moving on. And then it finds the 1 plus a half. Now what you did edge in on very quickly was the other side of this, which is we've now got 1 plus a half, but I took out my method. Oh, I should have got rid of that one. But I took out my method that was the adding the integer. But we can still do that as well. We can still say half plus 1. And the reason for that is that implicit conversion also works for the parameter. So now we've just taught this system how to convert any int to a rational, and it works both ways now. So we can do a 1 plus a half, or we can do a half plus 1.
Yeah.
That's very common. That's a very common use for implicit conversions. Now that we finally got to this point, all of that was to tell you that most of the time you shouldn't use these. These are occasionally very useful. I don't think, in this case, could you have done? I think you could do no, you can't do you can do an extends. You can't do an extends AnyVal with this one, certainly. I think you might be able to get away with an implicit class somehow.
If you're using ints for the rational.
Yeah.
So what you could do, if you wanted to, you could encode this class as a long. So you could have a long that extends AnyVal and then split it in half for the numerator and denominator, because that's awesome.
That's a bit torture. This is one of the cases where I would still, at the moment, use a proper implicit conversion. But what we're going to talk about in the rest of the talk is that, as you noticed when I did this back here, it actually said, warning, there are 1 feature warnings, rerun with dash feature for details. If I ran it with dash feature, what this is telling me is it's now a compile warning. It's a compiler warning in Scala. If you use an implicit conversion and you don't tell it explicitly that I know what I'm doing, I want to use this. And that's because this feature does lead to a lot of trouble. It does lead to a lot of confusion. Here's something you shouldn't do. Implicit, but you can do, that's the problem. Implicit str to int. Very tempting. We're going to take a string, and we're going to return an int, and we're just going to take that equals, and then we're just going to do s.toInt, which,
I think it should always return 5.
Oh yeah, okay, we can do that.
Yeah. 5.
Within the rules of what we just did. Now, I can say, have I still got square defined? I think I've still got square defined. Yes, I have. So I can say square Freddy. No, that didn't work because it's square I. Sorry.
Oh.
Because it actually needs an int. Okay.
But that's the right answer.
It's the right answer, but you shouldn't do that, okay? That's a very bad way to use an implicit conversion. We've now told it that you can use a string anywhere that an int is needed, and the value is always going to be 5.
I think in practice, well, I'm going to say we probably have one of these conversions in our code base of like 10,000 for the one project. So I'm going to say 1 to 10,000 is probably a good limit for yourself, or just 1. This is a very, 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 very nice thing to use, but it's also one of those things that when you need it, you're so glad it's there. But you should definitely not overuse it, and it's the most commonly overused feature of Scala
Yes.
when you first start.
When people say implicits are the devil, this is the one they're talking about.
Yeah.
I see a couple of hands up, so let's go with those. So the question is, the way you explain it, it sounds like the compiler has a lot of things to do. Yes. And does it affect the compile times? Yes. Scala is one of the slowest compiling languages that I've dealt with, and that's because the compiler is working so damn hard. We're going to show you a lot more that it's doing, or that it can do with implicits as well. But yeah, using implicits will slow things down.
Yeah.
So that's another reason to go easy on them.
So one of the basic rules of these is if you're going to make an implicit conversion in this sense, it should be from something to a type that you have created, which is in its own world. You should not try to convert like generic things. Like we tried to convert from Scala collections to Java collections using implicits, not explicitly but implicitly. And what this led to with confusion was you would take a Java object and you would create a Scala object on top of it, right? So if I wanted to use Scala methods, I just write them right on the Java object. That's great. The problem then is if I pass this guy to a Scala method, it's in a box. And identity is destroyed. If I want to pass it back to Java, I'll pass it back, and it gets a new box because it gets implicitly converted back from the Scala version to the Java version, and then Java gets back this collection, and it does maybe a reference equality comparison, because people write code like that, it fails. So that's one of the biggest problems with trying to do types that you don't control. But if it's like this rich int class where you tie it to rational class, you tie it to the rational class, that is like the best practices for implicit conversions.
Yes.
And when you have those classes, it's really useful and nice. We'll show you more about implicit classes, which guarantee you're doing this pattern.
Yeah.
If you don't have a class in that particular fashion, then you should really think hard about what you're doing.
So the next time somebody tells you implicits are the devil, this is the devil that they're talking about. It is very dangerous. It can be used correctly, as we've demonstrated. The use of it for rational here is fine. But there are now emerging patterns, and was it SIP 11? Kind of.
SIP.
It was SIP 11. Oh, well,
no, SIP.
SIP something or other.
Yeah.
Some number. When you change the Scala language, you have to submit a SIP, a Scala improvement process. And that's like a definition, a formal definition that people can look over. And one of the recent SIPs took several of these very, very powerful features that can be very useful, but are often abused and misused, and they put them into a state, a new form of the library where you have to import them in order to use them without getting warnings. And eventually they'll become compile errors, right? I think I don't know if it'll be in 2.11, but if you don't import these features specifically at the top, it will be a compile error if you try and use them. So we're going to show you after this all of the ways that implicits are not the devil, because that's the devil one. But I think what we should do is break for 10 minutes, give everybody a chance to do whatever you need to do, run around screaming perhaps, whatever you like. Just come back in 10 minutes and we'll pick up, and then we'll show you all the good stuff in implicits.
This is a great rocky staircase. Just
It
putting
is.
that out there.
It is.
If anyone's.
Rocky Horror.
Yeah?
Okay, 10 minutes. That will be 3:12. Is that right, Josh?
Yeah.
Do you mind if I... I'll tell you what, let me go and get